Welcome to the class. So last class we have discussed how to analyze the compound truss. So before that we have discussed simple truss. Now today we will discuss the last classification of truss, that is complex truss, and how to analyze the complex truss. So what is complex truss? First, let's discuss that. So complex truss means when the all members are connected in any manner. There is no sequence it will follow, but the entire truss will be stable. So for example, this is a complex truss, right? So here you will see so many unknowns will be there in the complex truss, unlike the simple truss. So simple truss is very easy to analyze. So you can use either joint method of joints or maybe method of section to analyze the structure, analyze the simple truss. Then we discussed about the compound truss, where basically we can use both the methods, method of section as well as the method of joints. So initially we used method of section to separate out all the simple truss, and then once we separated out all the simple truss, then we applied the method of joint to analyze the entire structure. But here in the complex truss, we have to use some other formula or some other methodology to solve the structure. So here also actually we can use direct formulas, like each joint has two equilibrium of equations. So total number of joints means that many number of equations, and each bar will carry one unknown. So in that also we can solve the complex truss, but it will be very much difficult because all the 2j equations, 2j means number of joints. So for example, here 1, 2, 3, 4, 5, 6, 6 joints. So 6 into 2, 12 equilibrium of equations we have to solve simultaneously. Then only we can solve everything. So it is very difficult to solve all the 12 equations by manually. So we need to help. We need to take help from the computer. But another easy way is there, by hand we also can do that. So that is, today we'll just discuss that method, that is method of substitute members. So what is this methodology tells is, first is, this is our original complex truss. Now we convert this complex truss into a simple stable simple truss by removing some of the members. So that by inspection we have to identify which member shall we remove from the complex truss to make it as a simple truss. And that truss also should be stable. So our first step would be to make the truss into a simple truss, stable simple truss. So for example, here we have removed AD bar. So here if you see, AD bar is not there. So AD bar we replaced in some other location. So that is our first step. First step is to remove one of the member, because if see this all the supports, actually all the joints has actually three unknowns. Three bar means three unknowns. So but we have two equations, right? Two equations for each joint. Summation of all the horizontal force equal to 0, summation of all vertical force equal to 0. But in each joint, if you see, all the three members are connected, so we can't solve basically directly. So what we have to do is, first we remove one bar and replace it in some other location. So AD is removed and we replaced his to EC. So now in the joint A, actually it is a now simple truss, because we have here two unknowns, and easily you can compute as a simple truss. So what we did is, we just this originally the one bar was in AD. Now we removed it and we placed it in some other location, and then we can solve this truss. This is a simple truss. We can solve this truss using method of joints, because starting with joint A, so here two unknown are there, so we can solve it. Similarly, now come here also two unknowns will be there, we can solve that. Go there, here also two unknowns are there, we can calculate both the things. Then if any zero force member is there, that anyway will be separated out. So just making a simple truss, then we can determine all the values here. Now next step would be, so where we have removed the bar, in the same location we have to apply one unit load, here. So but we have to remove the external load and we apply a unit load in that location. And then now using this structure, now we'll again use method of joint, we'll compute all the member forces. Then we'll just superimpose both the things, then we'll get our final value. So that's how actually the process will go. So basically we follow these four steps for method of substitution. First method is reduction to stable simple truss. That's what we discussed. So this is a complex truss. We removed one force, one bar, and we made it into a simple truss. Then next one is external load on a simple truss. So we compute this simple truss with external load. All the values will calculate. Next step is remove the external load from the simple truss. Then next step is this one. We remove the external force. External force P was acting, that we removed from here, and and we have applied unit load in the direction where originally our bar was there. And then then the superpositions. Then we superpose this one and this one, equating this bar should be zero. So we'll just find it out with zero force. We calculate and we superimpose both the cases. We'll get our main structure and we'll also get our all the values, required values. So just one example, I want to demonstrate all the processes at least. So here you can see this is a truss. It is obviously complex truss. So our first step would be is to make the complex truss into a simple truss by changing or substituting one of the member. So we can, so you see all the joints has actually three unknowns. So that's why it is actually complex truss. We cannot use a method of joint to compute all the forces in the truss. So what we have to do is first is we'll just remove this CF bar and place it into BD. So we removed CF and we kept it in BD. So that is our reduction to the stable simple truss. So this member we removed and we kept it horizontally. So this is the figure. So now we made it little bit simple truss, and now starting with this point we can calculate what is this to value. Like that we compute all these values for this reduction of simple truss, and we record all the values whatever we got each in the next slide. Actually we have a one table. So whatever member force is there in AB, BC, CD, all actually will record in a table. Now in the next step is what? Remove the external loading. So external loading was 5k if you remember. So using 5k only we solved this one. Now in the next step is we removed 5k. 5k was the now we removed, and we applied unit load in the location where we have removed the bar. So this bar was removed in this location. So we have to give unit load in that location, and no other external force. External force is not there. So now this figure, now we have to, we will just solve it method of joint, starting with maybe this point. Just entire structure will rotate and will, I mean, external, all the joints will go and will compute all the values here one by one, and then we record all the values in the tabulated format. So first one was, after we make our structure into a simple structure, all the values we recorded means CB, what is the force CD. So each bar, what is the corresponding value, we kept it. And this one SI was that second figure, that is after applying the unit load, how it will behave. So that after applying only unit load, this is the value we got. Now next one is what? But in the original structure, see this member is not there, right? In the original structure this member is not there, and all the member will be there in this location, and it will have some value also. So we don't know how much is the value of that bar. We have this second line SI is computed by using the unit load we applied in this bar, and we computed this. So now what will be the S dB? So SDB, so this bar, actually it should not be original figure, this bar is not there. We just replaced this one and we kept it like that. So now what is SDB? SDB equal to S dash dB. X dash dB means it's simple. When we analyzed first one, this first line, that if you remember last slide, first step was to make the truss into a simple truss and do the analysis. So that's what we did. This is first line, and second line was this one, that after applying the unit load, this is the second line. So what is the force at this dB? So dB will be S dash dB. S dash dB means after applying the external force, how much force load is coming here, plus uh, if this bar carries X load, we don't know. So we computed using unit load, that is the value. Now let's assume that that bar, if originally this here one bar was there, that bar carries X load, then X into dB. If for unit load, the value of this section was small s dB. Now we consider the original, if original bar when it was there, the force of this bar was X. So using superposition, S dB will get it S dash dB. S dash dB is for external force and X into S dB is for internal force. So this should be equal to 0. Why? Because this S, that's BD, is actually not there. It is non-existent. But we replace this into this. But in original structure, this is not there. That's why we kept it equal to 0. So substituted as dB. So as dash dB, from here you can see that uh, dB is minus 2.5. So we kept it minus 2.5 plus x into s dB. S dB is minus 1.167. So 1.167 computed and we got x value is this much. So what is x? X is actually in this member, which is the bar earlier it was there. We removed that bar, so that bar carries that much of load, axial load. So now next, this bar, this line xi is basically x is 2.14. This multiplied by this si. So 2.143 multiplied by 0.707, you will get this value. Same, this value into x, you will get this value. So entire line just multiplied all the value si1 into x, you will get this line. So now last step is basically using the superposition, using the method of superposition, just add the final thing. So this S1, if you remember, was the simple truss with external load. We removed this one, and SXI is with this bar. If there is a bar and if the value is X, then how much other member will the load will be distributed. That is this one. So now total SI means total final load in each bar will be equal to SI plus SXI. So this is the thing actually. So originally that simple stress, simple truss value plus X into SI value. If you multiply, if you add both, you will get this SI. So this is our all final values of a complex truss. So that's how actually we solve complex truss in general. So our basically we have to follow 3-4 steps. First one is make a complex truss into a simple truss by substituting a bar and make and place it in some other location. Then second step is that analyze the simple truss using the external load. Then third step is remove external load and apply unit load in the location where you have removed the bar, and do the structural analysis, do calculate method using method of join, find out all the member forces, and then substitute x, consider this x into xdb into s. From here you will get the what is the value of x, and then you substitute s into all the values here si, and just add it and you will get the final value in the all the members. So that's what we discussed. We completed this truss content. So we discussed about simple truss, and we discussed about how to solve the compound truss, and now we discussed about the complex truss. Thank you so much.